Question 5. The line L has intercepts P and Q, where P and Q are positive integers. What is the gradient of line L? Now the first thing to note is that this is a downhill, which means that the gradient should be negative. So we're only going to consider options A or B. So C and D are clearly out. Next, it's important to note that the gradient is found by the formula rise over run. So the vertical distance divided by the horizontal distance. So the vertical distance is P divided by the horizontal distance of Q. So it's clearly option A. Gradient is negative P divided by Q. Question 8. Dots were used to create a pattern. The first 3 shapes in the pattern are shown. The number of dots used in each shape is recorded in the table. How many dots would be required for shape 156? Firstly, let's determine the rule for this table. As S, or S represents a shape of course, but as S increases by 1, N increases by 2. So part of the rule would be N is equal to 2 times S. But that's only part of the rule. If we chose a random column, let's just say S equals 3, so third shape, we know that we need 10 dots. But 2 times 3 is 6, but we're off by 4. So we need to add 4 to complete the rule. Now to work out the number of dots. So N is equal to 2 times 156, so that's the shape number, plus 4. So let's calculate that. 2 times 156 plus 4 is equal to 316. The answer is option A. Question 13. Conversion graphs can be used to convert from one currency to another. Sarah converted 60 Australian dollars into euros. She then converted all of these euros into New Zealand dollars. How much money in New Zealand dollars should Sarah have? Now I've done the solution already, so I'll go through that now. There are 2 graphs. The first conversion graph shows the conversion between Australian dollars and euros. And the second conversion graph shows the conversion between euros and New Zealand dollars. So the first part of the question is, Sarah converted 60 Australian dollars into euros. So referring to the first conversion graph, 60 Australian dollars into euros can be found by firstly locating 60 Australian dollars on the x-axis, drawing a vertical line until you strike the diagonal line, and then drawing a line horizontally, so projecting a line horizontally to the y-axis, and then reading the value of euros off the y-axis. So in this case, 60 Australian dollars equals 45 euros based on this conversion graph. Now using the second conversion graph to convert euros into New Zealand dollars, locate 45 euros on the x-axis, draw a vertical line from that point upwards until you strike the diagonal line or the graph itself, and then from there project across until you strike the y-axis. And that point there is between $75 and $80. So the answer is option C. Question 7. Which of the following is the graph of y equals 2x minus 2? This is in the form y equals mx plus c. So the m represents the gradient, so the gradient's 2. So from left to right, the line is rising, and the negative 2 indicates the y-intercept. So let's consider the y-intercept first, because that's kind of the easiest thing to look at. That's a y-intercept of 2, so it can't be b. That's a y-intercept of negative 1, so it can't be c. So we have an option of A or D. Now with A, the gradient from left to right is negative, and for D, the gradient from left to right is positive. The gradient's positive 2, so the answer must be D. Question 26F. The weight of an object on the moon varies directly with its weight on Earth. An astronaut who weighs 84 kilograms on Earth weighs only 14 kilograms on the moon. A lunar landing craft weighs 2,449 kilograms when on the moon. Calculate the weight of this landing craft when on Earth. So this is a direct variation question, which is based on the direct variation equation, y equals k multiplied by x, where k is the constant of variation. So rather than using the pronumerals x and y, so x is the independent variable and y is the dependent variable, I'm just going to use the nouns moon and Earth. So moon, or the weight on the moon, is equal to k multiplied by the weight on the Earth. So we need to determine this constant of variation k. And we do that by using the data in the question. An 84 kilogram person on Earth weighs only 14 kilograms on the moon. So substituting those two values into the direct variation equation, so we've got moon equals 14, Earth's equal to 84, so 14 equals k multiplied by 84, making k the subject of the formula by dividing both sides by 84. We have k equals 14 over 84. Now to determine the weight of the lunar landing craft when on Earth. The way we do that is to substitute this weight, 2,449 kilograms, for the moon, because that's what this lunar landing craft weighs on the moon, is equal to k multiplied by the weight of this craft on Earth. So 2,449 equals 14 over 84 multiplied by Earth. Then we're going to make Earth the subject of the formula by dividing both sides by 14 over 84. So 2,449 divided by 14 over 84 is equal to the weight of this craft on Earth. And that's equal to 14,694 kilograms. So therefore, the weight of the landing craft on Earth is 14,694 kilograms. Question 13. What is the equation of the line L? So this is this line here. First thing we need is to find the Y-intercept. That's the easiest thing. Y-intercept is 2. Okay, so this is going to be in the form y equals mx plus c. And we have found the Y-intercept. So it's y equals mx plus 2. Okay, but we need the gradient as well. Now, going from left to right, or moving sort of from left to right, the line is starting up high and ending up a lot lower. So it's a negative gradient. So it's certainly not option B, and it cannot be option D. Both option A and option C have negative gradients. So gradient is equal to rise over run. And we can use this right angle triangle here to help us determine that. Now the rise is a negative rise, so starting at 2, ending at 0, so it's actually dropping 2 places. So represent that with a negative 2 over a run of 1, and that's equal to negative 2. So the equation is y equals mx plus c negative 2x plus 2, and that's going to be option A. Question 14. The graph shows a line which has an equation in the form y equals mx plus c. Which of the following statements is true? So we're commenting on the gradient and the y-intercept. Now, going from left to right, we can see that the line is rising. So clearly m is positive. Okay, so that immediately rules out option B, and in fact option D. Now the y-intercept, okay, is the point where the line crosses the y-axis. It's under the origin, so the y-intercept is negative. So we have a positive m and a negative plus c, or a negative y-intercept. Okay, so the answer is option A. Question 20. A pentagon is created using matches. By adding more matches, a row of 2 pentagons is formed. Continuing to add matches, a row of 3 pentagons can be formed. Continuing this pattern, what is the maximum number of complete pentagons that can be formed if 100 matches in total are available? So what we can do here is to form a table of values. I might just draw it here. Okay. Okay. And we have let P be the number of pentagons and M the number of matches. So we have 1, 2, 3 pentagons. So when we have 1 pentagon, we have 5 matches. When we have 2 pentagons, okay, if you count the number of matches there, we have the original 5 plus 4 gives us 9. Now 3 pentagons, okay, you have the 9 matches originally from the 2 pentagons. We're adding another 4 matches, and that gives us 13. Okay, so the formula is going to be number of matches is equal to 4 times the pentagons, or 4 times the number of pentagons. And the reason for that is because for every increase in the number of pentagons, for every increase of 1, it's an increase of 4 matches. It's like a gradient, so it's gradient of 4. But this isn't complete. When we have 1 pentagon, so 4 times 1, okay, that gives us 4. We're meant to have 5 matches, but 4 times 1 gives us 4, so we have to add 1 each time. So let's check it quickly. 2 pentagons times 4 gives us 8, plus 1 gives us 9, so that's correct. What about 3 pentagons? So 4 times 3, that gives us 12, plus 1 gives us 13, so that's correct. So we can use this formula now. So we're given here that, that we have 100 matches. Okay, so let's solve this. 100 is equal to 4p plus 1. So we need the number of sort of whole pentagons that we can form. Subtract 1 from the left-hand side. So 99 is equal to 4p. Okay. So we're going to divide 99 by 4. So p is equal to 99 over 4. And we get 24.75 pentagons. But in terms of the number of whole pentagons, you don't round this. It's going to be 24 because 0.75 of a pentagon is not a whole pentagon. So the answer is B. We get 24 whole pentagons, or complete pentagons. Question 14. Last Saturday, Luke had 165 followers on social media. Reese had 537 followers. On average, Luke gains another 3 followers per day, and Reese loses 2 followers per day. If X represents the number of days since last Saturday, and Y represents the number of followers, which pair of equations model this situation? Now, the numbers 165 and 537 represent a Y-intercept. So I would expect the Y-intercept for Luke should be 165. So clearly option B could be 1, but not option A. Nor option D for that matter. The Y-intercept here is 3. So we've got a choice between B and C. Now, let's have a look at the number of followers per day, or the gain or loss, the number of followers. Luke gains 3 followers per day. So I would expect a gradient of 3 for Luke. Reese loses 2 followers per day. I would expect a gradient of -2 for Reese. Now X is the number of days that passes. So for every day that passes, Luke is gaining 3 followers per day. Reese is losing 2 followers per day. So I expect to have an equation that models Luke's gains to have a 3x in it. Here it is. Also expect an equation that models Reese's losses to be -2x. And here it is. So the answer is option B. Question 34. The relationship between British pounds, P, and Australian dollars, D, on a particular day is shown in the graph. And in particular, have a look at this point here in the graph. So this point here implies that 7 Australian dollars gives us 4 British pounds. Part A. Write the direct variation equation relating British pounds to Australian dollars in the form P equals MD. Leave M as a fraction. So direct variation implies that it starts from the origin at 0, 0. So we only need one point or one known point to work out the gradient M, okay, or the constant of variation if it's the letter K. So P equals MD, pounds, 4 is equal to M times the amount of Australian dollars to give you 4 British pounds, which is 7. Making M the subject of the formula, so rearranging the equation, we have M is equal to 4 divided by 7. 4 over 7. Therefore, the equation is P is equal to 4 over 7 D. Okay. Part B. The relationship between Japanese yen and Australian dollars on the same day is given by the equation Y equals 76D. Now, Y is yen, D is Australian dollars, so very similar to the last question. Convert 93,100 Japanese yen to British pounds. So there's 2 steps involved here. First of all, let's convert the Japanese yen to the Australian dollar, because from there we can use part A to convert Australian dollars to British pounds. So let's work this up. So Y equals 76D. Okay. Now we have 93,100 Japanese yen. So 93,100 is equal to 76 multiplied by Australian dollars, dividing both sides by 76. So D is equal to 93,100 divided by 76. D equals, okay, so 93,100 divided by 76, and we get 1,225 Australian dollars. Now we need to use part A to convert 1,225 Australian dollars into British pounds. So from part A, okay, P is equal to 4 on 7 times D, which is 1,225. Okay, multiplying that together. Okay, so 4 on 7 multiplied by 1,225, and that gives us 700. Question 6. Suppose y equals -1 minus 2x. When the value of x increases by 5, the value of y decreases by, some options there. So I think the first thing to notice is that the equation really is in the form y equals mx plus c. Okay? In fact, I might just rewrite it a little bit differently here. I'm just going to rearrange it just so you can see what's going on. Okay, so I'm going to put the -2x first and then -1. So the gradient's -2. So what does the gradient represent here, or what does it mean in terms of the values of x and y, or that relationship between x and y? -2, this gradient means that when x goes up by 1, y goes down 2 places, or by 2. X goes up by 1, y goes down by 2. So if x is increasing by 5, that means y is decreasing by 10. In fact, the -1 here has nothing to do with it at all. If we're just talking about x changing in a sort of by a particular quantity, y will change accordingly, but multiplied by whatever the gradient is. Okay, so the answer is 10. Now, just for your benefit, if you just want to see this a different way, you could actually do a table of values, in fact, and you could probably see this fairly quickly, in fact. So x, y, and Let's try some values here. So 0, 5, and 10. And we can use substitution here. So when x equals 0, substituting it into the original formula here, -1 minus 0 is -1. When x equals 5, okay, so we have -1 minus 2 times 5, we get -11. Whoop, I'll just put that on the screen there. Yep, -11. Okay, and when x equals 10, we get -21. So x is going up by 5, y is going down by 10. So that's another way to be able to see the answer. Question 10. A plumber charges a call-out fee of $90 as well as $2 per minute while working. Suppose the plumber works for T hours. Which equation expresses the amount the plumber charges, so that's C dollars, as a function of time, T hours? Now, let's go back to the question. Plumber's charging $2 per minute. Now, but T's in hours. So we need to convert this $2 per minute, okay, per minute into dollars per hour. So there's 60 minutes, obviously, in an hour. So if we multiply that by 60, we end up with $120 per hour. Okay, so for every T, every increase of T by 1, so an extra hour worked, it's an extra $120. Okay, so looking at the options there, we're charging $90, so that's just an upfront charge. So it's going to be 90 plus something. Okay, so this 90 is not dependent on the amount of time that the plumber works. So the 90 and the T cannot be together. So it can't be A and it can't be C. Now, let's look at option B, 90 plus 2T. T's in hours. So if the plumber works 1 hour, the plumber charges then $2. So that doesn't make any sense. But we've done some work previously to show that $2 per minute is really the equivalent of 120 per hour. And that leaves us option D as our only viable option. In fact, the correct option. Okay.